I'm excited to be here and to tell a story that I think needs to be told. About my agency, we work with private landowners within the state of North Carolina. We also manage state land, and we work with a lot of organizations and partners to conduct forest management within the state. Unlike New Jersey, I think our state is very friendly, being able to conduct management practices. So before my ascension to an administrative forester, I was a field forester, a dirt forester, a researcher. So my presentation today is going to be part history, it's going to be part research, and it's going to be part future, looking ahead and giving a sense of why Shortleaf's important, and some projects that are important to the future of Shortleaf. As a practitioner, I think there's a role for tree planting. How many out there in the audience plant shortleaf pine or trees? Okay, that's good. At least I have a good audience here. So the title of my presentation is Shortleaf Pine Progeny Test Performance in North Carolina, 30-year results. A lot of times you'll hear presentations from 1 year and 2 year, but not often do you hear long-term results and perhaps some of the implications. I do have a goal for my presentation. I know what you're thinking. You're probably thinking, why shortleaf, right? But my goal is to provide an interesting talk, to highlight a successful state and federal partnership. This project here was a joint effort between U.S. Forest Service. Some of the members that were part of this project can't be here, so I'm here to tell their story and acknowledge their efforts as well. I also like to present project results and implications for restoration. What does it mean? What do these projects mean going forward? And hopefully generate future interest. I think this, Mike would agree with me here, is the primary purpose of this type of meeting, to network, to hear some interesting stories and say, I like that, I want to do that, or hey, I've got this in my state, you know, how about we take a look at it? So before I dive into the results, please let me set the table. It's going to take a few slides, but I think it's still important to kind of look back. When you're looking at shortleaf pine in the eastern part of the range, there's really a limited synthesis and review regarding shortleaf pine genetics. Within the eastern part of species range, there's plenty of it in the western part, but go ahead and Google and try to find current research, current literature. So it begs the question is, what do we really know about the adaptability of shortleaf pine seed sources across its range? Are we sharing information about our tree planting projects? Are we borrowing genetic material from other states when we're out of local sources? The other thing that's a challenge for shortleaf pine management is, when you think about it, is the pine genetic and tree improvement funding efforts have largely focused on advancing loblolly pine generations. I'm still blown away by the amount of money that's thrown to study loblolly. I think if you look in the literature, everything's already been done. They're just reinventing it or calling it something different. I mean, the only thing they haven't done is made a square tree, right? But that's the challenge, is when you're comparing the growth sometimes of planted loblolly versus shortleaf, you're comparing a third generation 3.5 versus probably first gen or even wild sometimes. So it's not a fair comparison. So hopefully we can bridge that gap with some more of these projects and studies. The other question, you know, to think about during this presentation is, what does the future hold for shortleaf pine genetics for restoration and management? How are we going to get to the end goal, right? Do we have the capacity? And can we do it alone? Probably not. This was the paper that did it for me. It was a forest science paper looking at most of the early genetic research effort focused on provenance variation of pine species, the Southwide Southern Pine seed source study in the 50s. This is a map of shortleaf pine. Some of the early work, what they did was they had plantings, they had different sources, they compared them east, west, north, south. They found that, you know, southern sources did well if moved up. Local sources, if they're planted in the north, did well. But what they did was they kind of broke it up into zones. So I want you to kind of visualize this map and the zones that they used, 1, 2, 3, 4. Our study took place in zone 3 and 4. And this is kind of a recent version. This came out in 2000 for a lot of us plant trees. This is kind of our Bible. You can see the reference publication there, Guidelines for Southern Pine Seed Sources, Ron Schmitling. This work, they moved away from zones. What they did was they used climate, they used isotherms. And the general premise, this is a map for shortleaf pine, is if it's planted within, 5 degrees, you should be okay. I can tell you, even looking at our state with loblolly pine, we've been rethinking this map, these guidelines, particularly in the face of climate change and what we know. Even for cost share projects for loblolly pine, we decided that we were going to cost share projects up to 8 degrees. So our original standard was 5 degrees, but we felt it was appropriate to move some southern sources up, looking ahead. So beg the question, is it time to revisit some of these? Looking at the maps, how will they be impacted with climate change? I think we have some researchers looking at that, looking at some new guidelines and what we need to do. So looking at this project, again, it's a state and federal partnership project in North Carolina. It really began with a joint meeting back in 2010 with some key agency personnel, and I list them here. The interesting thing about this is the people that are here, several of them have since retired. So even within my agency, James West and myself are still here, and Barb Crane and Robin Taylor are still here, but they're planning to retire in the next year or two. So a lot of intellectual capital, a lot of work went in early on trying to forge a partnership. To do this, we had to sign an MOA, working with the National Forests and our agency. Our goal really this meeting, you can see it here in the bullet, we wanted to ensure that the current seed orchard capacity of the Appalachian seed source is not lost. And we also wanted to utilize some new shortleaf pine sources from available Progeny Test or legacy orchards. We developed a plan to preserve current germplasm, try to incorporate new sources for restoration, utilize some new material, and then begin development of a new seed orchard with original first-gen selections and second-gen selections, and I'll talk a little bit more about that later. Just a general history overview, there's some past efforts are documented in the literature in some conference proceedings or online. I found this paper, and Dana's here, The Genetics of Shortleaf Pine with Implications of Restoration and Management. If you can find it, it's a really good read. It's a good paper. Mike, a shameless plug, we got one on the initiative as well, a fact sheet. I wasn't the best available to write that, but I was the only available. So I did my best to kind of bring together what we knew and where we're going with it. So the story revolves really around the Beech Creek Seed Orchard. This orchard was established between '63 and '68. It's in Murphy, North Carolina. For those of you that work in the southern region, it contains the breeding population number 4 and number 5, and I'll show you a map here in a little bit. But really how that orchards and a lot of orchards got started is they were 50 established families from geographic sources. They selected them from National Forest. They had candidate tree species that had a whole ranking criteria that they used. Just a lot of effort went in years ago, and it's hard to believe it's going on 60, 70 years now. They also had 4 other locations that they established. I think there's Arkansas, Louisiana, and Mississippi. There's one in South Carolina in Monk's Corner. They were primarily the Georgia sources, but Hugo kind of took that one out. So really there's only 4 left, 4 orchards on federal land. There's some state orchards that are still out there, but probably not to the degree that the feds are managing theirs. So looking at shortleaf pine tree improvement, progeny testing began in the 1970s or so for first gen, and then into the 1980s, particularly in the southern region. There's good papers on that as far as the history, what they looked at, what they found early on. Here's a breeding map of shortleaf pine and the breeding populations. You can see some of them up here is 4, I believe. Yep, and then 5 up here, which is in Kentucky and Virginia. And then the other ones, Mississippi here, and then the other are west of Mississippi. So that's where a lot of the families and the selections came from in their orchards. For those of you, maybe Shortleaf 101, Mike, right? Kind of where we're at, where we've been. We talked about provenance tests around the 50s and 60s. They looked at them, genetic, geographic variation. This is kind of where we're at today, really. Natural selections, we're in the trees. We have first-gen orchards out there. In the 1970s, they looked at some progeny tests, and then what they did was from those tests, they kind of rogued their orchards. So in the first-gen orchards, you kind of have the best of the best that's out there. And some of those are still really nice selections. There are some second-gen tests that were done. I know in Arkansas, they were the first to complete their breeding plan or program, and they've done some research on that. You can find it in the literature. And they did some genetic tests, and from that, what they did was create second-gen seed orchards, and then trying to bring some seed production. So really, that's kind of where we're at today with this talk. But keep in mind, a lot of the shortleaf pine, the seed sources come still from first-gen improved orchards or selections that were made. In North Carolina, looking at the progeny test, we had 19 tests that were established on national forests between 1982 and 83. That's a considerable amount of work if you think about it. It's almost 2 per year. And I just want to stress the amount of work and effort that went in back in that time period. I think the U.S. Forest Service had some of the preeminent nursery people, genetics, field person, and researchers. So a lot of effort went into these over the years. They were on 6 National Forest Ranger districts. Person on the left is John Blanton. John's a big shortleaf fan. He was a silviculturist from North Carolina National Forest. John visited a lot of these in 2010 and helped us to at least find the ones that were still intact, still worthy of a visit, still worthy of investigation and measurement. So 8 of them were still left that we felt. We measured and evaluated them in 2012. North Carolina Forest Service put together a couple crews, 3 or 4 people. We planned for a whole week, and what we did is we divided and conquered. We visited, we worked together to measure them. I want to say this is, I'm sure there's plenty more out there in some of the other states. So if you're on some of the national forests and you know about them, let Mike and myself know, and we certainly would like to at least try to revisit some that are still out there and see if we can preserve them, see what we can do with any of them that are still intact. So, took me 10 slides, but here I am. This is kind of the meat and potatoes of the presentation. What I want to do is just show what the field performance of the shortleaf pine full sieve families through 30 years. Again, we had 8 locations, and the interesting part of this is we had 4 of them in what we call our Piedmont region, and 4 of them what we call in our mountain region. Here's the Beech Creek seed orchard, and here's ours. We had a legacy orchard here and a new orchard, but you can see some of the national forest land. And remember the map I showed you before. These 2 are located in different planting zones, seed zones, excuse me. The other thing about a full sieve family is when you're looking at evaluating progeny tests, it allows you to evaluate not only the cross that's made, but also the parent, its legacy or its lineage. So here's what they look like. Interesting, they're both the same age. These were planted in 1983. The one on the right is in a typical Piedmont in the Uwharrie National Forest. And this is the one in the mountains here in the Nantahala, but you can see this is in the summertime, but a little more hardwood component. These were traditional plantings where you had different families or crosses went down the row and they went up the hill. And I'll tell you a little bit more about them. Briefly, just the methods if you're kind of a scientist or researcher and you like to know. Here's kind of the breeding design. There were 99 full sieve crosses representing 30 geographic sources. The crosses included parents from different states as well as from within states. We had 4 check lots in each test. They were planted in 10 tree plots with replication, and there was enough duplication to allow combined analysis. As I mentioned earlier, the breeding population that was evaluated, 4 and 5. When you look at 4, what it includes is 3 states. And just because it's a state here, they were sources from the national forest. So Tennessee one is the Cherokee. in North Carolina 2, it includes the Pisgah, Nantahala, and the Uwharrie. And for 3, Georgia, way down there, Mike, in your land of Chattahoochee. They did have some from Virginia, but no Kentucky sources were evaluated. We had some check lots from general forest areas. We took the standardized measurements that were taken in year 5 and 10. They were first interval evaluation, second interval evaluation that the feds typically do. I think some of this data was on floppy disk, old school, so we had to get a hard copy and retype it. We re-entered it, so it took a lot of work to do that, but we were willing to do it. Here's some of the measurement protocol that we took: height, DBH, straightness, insect disease. We used the same protocol for year 30, except we looked at volume as well. I didn't do the analysis. Mr. Ken Roeder, who's since retired, he did the SAS analysis. He did all the number crunching, so you're going to have to call him for a little more detail if you need it. And hopefully I'd like to stay just broad level and not get too far into it. But they were analyzed. They also looked at NC State Tree Improvement Co-op helped us out. They also took the survival and volumes and they standardized them into a performance level, adjusting for the test mean and standard deviation. Because they're different ages, you had to do different things. So really what we looked at was survival, height, and volumes, and we compared them by forest region, test sites, genetic cross, and parent source. For those of you that are statistical, you get some numbers. I thought I'd give you a couple tables to just look at. This one is survival, cross survival. The biggest thing to look at here, they're color-coded. Lighter color is highly significant, and the other green is a little less. But if you look at them from age 5 to 10 to 30, they were still significant. So survival was highly significant by region and also by test site. And there were significant differences in survival by the crosses that they had. Looking at the parent survival, looking at across the regions, there were still regional differences in parent survival, and then test site as well. A lot of highly significant in test site and parents. So there were some tremendous parents that stood out for the different test sites that we had. Here's some survival results if you're kind of interested in how it changed over time. Just to give you an idea, these were planted on 8x8 spacing, 681. That's old school. I think we plant about 8x10 now, a little wider. The interesting thing about the 30-year data was we found these that nothing really was done. There was no thinning, no pre-commercial thinning. It really was survival of the fittest. You know, no thinning, natural mortality. So the premise would be, you know, these 30-year-old ones may have withstood some beetle activity, some ice storm, some diseases. So what you have out there are probably ones that maybe are willing to be long-term, longevity. Age 10, if you look at it for the mountains, 67 and 73, this is in line with some of the western studies around 72, Arkansas. So, but then what you see is with natural mortality is there's some differences. Most of it's probably the hardwood component and some site differences changing the survival, but still pretty good. The biggest take home was that parent survival was highly significant across all ages. Looking at height, similar results. There were significant differences in height based on the crosses that were made, and also looking at the parent height. The interesting thing about height is there were early differences at 5 and 10, but sometimes those differences weren't as strong at age 30. But the main part is the parents were still significant. So the top performers early on were still the top ones at 30 years. And as with other pine species, the analyses indicate that shortleaf pine height growth is highly dependent on site quality. You saw that out there, I think, in some of the pine lands, the different sites, the tree size and the heights, and we certainly have that in North Carolina. So again, the genetic cross height and parent height were significant at age 5, 10, and 30. Early height performance, like some of the other research has shown, is still a good predictor for parent or family performance. So some of the top ones weren't the same ones, but they were still in that upper class. So if they performed well at 10, they seemed to maintain that good performance. Just to give you a a couple slides of it, even the importance of height, early height in the mountains. When we're planting trees in our sites, is a lot of times they're mixed sites. They're hardwoods in there, so I look at shortleaf, it's kind of like an umbrella that's been blown together in the wind. You know, one that can get its crown up in the upper canopy and then start to unfold it are the ones that seem to survive and do well. Picture on the right is at 30 years, so you can see the ones that were dominant were able to get their crown up early, maintain it in the canopy, and also maintain that place, that dominant place in the stand. So it is a race, I think, to canopy closure and maintaining its position. Just touch on volume results briefly. We normalized them for the analysis, but what we found is there was no statistical difference in the standardized volume across the two regions, so the volumes were equally as good. They had the same, so if it performed well in the Piedmont, it performed just as well in the mountains, but they were significant, the volumes at age 30 and 10, so the top performers stood out in each test. We looked at a performance value is how we analyze. It's an old term school, an old school term. They think they use breeding value now, so what it is the combination of values for selected traits, and you can use this as a selection criteria and allows you to rank the top crosses. Here's what we found. Of the top 48 trees, 33 parents were identified. Many of the best performing crosses consisted of parents crossed with parents originating from another state. This was interesting to me. You would think the local source performs the best all the time, right? That's kind of a myth. Sometimes it's right if you're bringing sources from way outside, but we were pleasantly surprised by this. The ones that did well were the Tennessee and Georgia parents that were crossed, and also a check lot. One from a general forest area performed extremely well. Just a slide to stimulate you with numbers, graphs, volumes. But what we did, this is a ranking, so we were able to rank some of the top selections based on performance value, again, looking at them not only 10-year and 30-year, but again, this 904, 134 was a pretty strong performer in the 129, 345. Just to give you a little 101 is, this first one here is a Tennessee tree from the Cherokee, 29 clone, and this one's a Georgia with a 45 clone or source. So let me get in the results, show you some pictures. It's kind of what it looks like, these double flags, so the best selections you can see, right? You know one when you see one. They really stand out. This is just the corner of the rep, but looking at it, you can see some of the selections, and these are from the Uwharrie test plantings. This is the youngest one, but actually looked even bigger than the other ones. And you can see the differences in the height, the crown, the straightness. So some really fine individuals do stand out in individual tests and across all the tests across the two regions. So really allowed us to look across two physiographic regions. So this is the biggest thing, Mike, permit me just a few more, is the real benefit of this project was we were able to at least make some second-gen selections from these progeny tests. We collected some sign material. That was no easy task. They were up there, but we were able to do it. We did some grafting on the old, the new material and the legacy germplasm in 2012, grafted onto pitch pine, and then we outplanted them in 2013 at 2 locations. This is very important too. Not just one location, but the U.S. Forest Service has one, and we do just as a backup, as a secondary reserve, and it just makes sense. It's smart to do that. But it's really part of our agreement to share resources, genetic resources and personnel. So we have 2 of them. The new term now is Genetic Resource Management Area. So that's the new term that they're calling them. And I think it's fitting because they're preserving the germplasm. That's the biggest benefit of this project here, is we were able to make new selections, but also we were able to bring the best of the first-gen selections, archive that, and conserve that germplasm that was collected, years and years ago, that are still very, very good sources. So it gives you an idea of the numbers. And hopefully in the second presentation day, I'll show you a little more pictures, but some summary points from just our project and results, not just the research. I think this project was a successful partnership for shortleaf pine germplasm conservation. That orchard's been there a long time. It's getting long in the tooth, and to take steps today to have it, continue on in the future is really going to be a good legacy, I think, between the two agencies. The other thing is we were able to incorporate breeding southern sources with adjacent northern sources. And Dana, this is some of the strategy too, right, is to try to find seed sources from adjacent areas, breed them together, and hopefully that's going to, by selecting these crosses or sources, you're going to have this increased regional adaptability and maybe resilience if you have some change in climate. Barb Crane wanted me to also make this point is there's still a need for increased general forest area selections to ensure genetic diversity. So we weren't making these selections just based on like loblolly, the biggest volume cubic foot. So there's a combination of traits, but we do need some more sources, particularly in the southern Appalachian, try to incorporate more sources. And lastly, on the summary slide here, and I think we've all been saying it, if we're going to be successful, I think this future genetic work has to continue. We have to realize that through deployment of new planting material and cooperative outreach efforts by both state and federal agencies. So we're seeing more shortleaf being planted on U.S. Forest Service land, private landowners, and we want good material that they're going to have a successful project. But this effort here, any kind of genetic work, it's going to take a sustained collective effort from key agencies and organizations. It's really all hands on deck. We can't just rely on the U.S. Forest Service to carry us, the entire way. It has to be a partnership, and it has to be a collective effort that hopefully will come through this group and the initiative. So with that, I hope you enjoyed at least an interesting project that we were able to conduct last few years, and we're pretty proud of the work, Mike.